Okay, so today I'm hoping we can fix this problem of our vulture not colliding. Look at that. See how he should have bounced? He should have bounced there. So we're going to take a look. We tried to fix this yesterday, couldn't figure it out. But I'm thinking we can... It's like so annoying. It's just like one little piece that I want to figure out, you know? But if it's not figured out, it's really annoying. So it's hard to move forward before we fix this, so I think we just need to fix it. So I took out the buffers of these to make it more true collision, which I think is okay. Except for here. I guess I'm just taking out the buffer. I just want the true collision, I guess. Now, I had thought that since we cycle through each platform and we check bottom collides, see, we need to check bottom collides after our side collides. So check side collision first, then bottom collision. And upon our side collision, we don't only want to... Here we go. So, okay. So, here's what I want to do. Upon colliding and going faster than the threshold. So I guess that's important because... Or our collide timer. Meaning this is the first time we've collided. Because we don't want to swap our DX willy-nilly. Just want to swap it, you know, if you've got that collide timer, which right here, if our collide timer is bigger than this number, we reset it. And that number is in our constants, if we want to see it here. It's just 1. Okay. Anyways, we switched so that we're now detecting side collision before our bottom collision. And the bottom collision is where we're resetting our Y position, which I think is what was causing the bug. So if we're detecting the side collision first, we need to do something. We also need to reset our X. We reset our DX, but we also need to place our X. If we collide on the left, we want to set our left to be equal to our platform's X plus our platform's width to set us on that side of it. And then here, if right it collided, then we need to give our self.x to be equal to, or to be assigned the platform x minus a self.width. Okay. Let's see if that makes us bump now. Makes our vulture bump. Okay. Wasn't exactly the intended consequence. I think it has to do with the buffers we took out. Let me see. I guess let's just give us the buffers again. We've got that one. We need a minus buffer and a plus buffer on the top collides. Okay. Then we need what? Right collides has this buffer. So right collides has a plus buffer divided by 2. Okay. Left collides has a minus buffer over 2. I guess let's see if this treats us any differently. See, so now it's detecting the side collision, not the bottom collision, and that's screwing that up. So if we go to the spot we're doing our bottom collision, we move it to be before our side collisions, it'll be still the same old bug, but hopefully it fixes that perpetual crap. No, it doesn't. Well, shit, now we're screwed. Oh no. Well, it was nice knowing you guys. It was a good effort. We got pretty far. We are triggering a collision though. I mean, whatever we're printing. Are we printing it here? No. We're printing it here? Yes. Vulture 1 just collided. That could be anything. We're gonna say Vulture 1 colliding with I want to run okay, I don't know what to do. I don't know why it's all messed up like that now. Let's try to move it back. We had this. We had this. This was before. This was like the first thing. Okay. Let's see if we're busted. Hey, at least. Okay, we're making some progress. You know, we're detecting. I mean. It seems like it wouldn't make sense like that would be able to happen. Like how I screw up the code so bad that it would be able to do that, you know, but 60 frames a second, a lot can go wrong. You know? So I guess what's the first move? If we detect our bottom collision, we become grounded, we take away our gravity, And also grounded being true will take away our update to our delta y gravity. Resetting our y, or resetting our height. That's if you collide with anything. But the thing is, with our ground, okay, our ground platform is a little bit different. Our ground platform is not in our collidable platforms. And I don't know if that's correct. Excuse me. Excuse me, jeez. Swallowed that wrong. Oh, jeez. Okay. Well, what do we do? Let's test out, let's print out some debugging that can maybe help us. Well, it's just our vulture stuff isn't so airtight, huh? So it's almost like I wish I could kind of highlight parts, you know. Is there a syntax highlighting tool or something? Tag. Wrap selection with tag. Because it's like, I kind of want this whole thing. Gosh, all of this, right? No. Right here. This is the end of it. I want this to be kind of like collapsible almost, so I can, or highlightable so I can see that it's one chunk, you know. Or what's that? Selection? No. Okay. I don't know. I was thinking I could highlight it or something. I don't know what groups is. Oh, that's cool. You could comment the whole thing out like that, but okay. God damn. Okay. Let's just go through. Oh my god. We'll go through our vulture class and just see what might be causing so many bugs. Now, there isn't too much going on. There isn't too much going on. There's just a couple of functions. Okay. Okay. Fuck. Sorry guys, it's hard to wrap my head around all the lines of code. But this just sets viewport with spawning. So like, so this is the beginning of the AI logic, which we need to rehaul anyway. So I guess let's take it out and then kind of imagine how to reinterpret it. So we were doing a little jump counter, but we need to do something different. So if we're not spawning, first of all, we're running check grounded and bottom collides. So I guess we're running bottom collides first with the ground platform. And then check grounded. Now, does our check grounded function return just a value? Okay. Looking at our vulture logic, if we're check grounded with the ground platform, then we're assigning the ground platform. See, and how does this have access to this? I guess I'm curious how I can use ground platform even when ground platform is an object over here in play state. But I guess it's a global variable, so it can use it. I don't know. Where do we use this self.ground? Or not self.ground, but oh, see, look, there's a self.ground and a self.grounded. And we're saying, oh God, this is so backwards. Oh God. Oh, okay. Grounded is the flag I have when I'm standing on the ground and gravity's not applied. But self.ground is the platform instantiation of the object that you last collided with that is your ground. But that needs to get flushed if you walk off the side of the edge. But I don't see where I'm actually using this dot ground. Oh no, we're using it here. We're saying if we're... Oh, okay, that's where we're flushing it. We're flushing... Well, no, we're actually not flushing our self.ground. We're flushing our grounded, which is good, but we also need to say if we're not check grounded with our ground anymore, then our self ground gets deleted too, right? Our self ground gets this non-applicable platform name. Is that right? I mean, that sounds stupid to do that, but it can help us. I mean, we're supposed to flush it because it wouldn't be its dot ground anymore because it's not grounded at the moment. So assigning it, oh God, assigning it a new blank stupid ground platform name. I don't know. I don't know. We'll have to see. If we're not grounded, apply gravity, then modify our y position by our velocity, by our gravity, effectively, if we're not grounded. Then I'm saying we took these out. We took these out. Ensures ostrich facing direction of dx. So, I guess this isn't necessary for the vulture class because the ostrich can face a direction it's not moving, can face the direction opposite of which it's moving when it's in the air, but our vultures can't do that because there's no directional input. It's just AI, so we don't need it. Then we're saying if we're grounded, our height is a certain amount. If we're not grounded, our height is a certain amount. If we're jumping... Okay, so here's where vulture jumping height here. This is where we can start to tweak our vulture values, but look through a little more. So this, I'm setting jumping equal to false after we do the jumping logic, so it only gets applied once, which I guess is okay. And then I'm updating all of our vultures to have a dx of -1, which isn't necessarily the case. They need to have an assigned x velocity, meaning, I mean, it can be either way, left or right. And then depending on the tier of villain they are, whether bound or hunter or whatever the third one is, they could get faster, jumping more erratic. Okay. Okay. So here we're setting, this is wild. Like, what sense does this make? Right? We're saying there's an FPS field in our vulture object that we're assigning the value this. What does this evaluate to? We're taking the absolute value of our dx, multiplying it by 0.42, and then subtracting. That's wild. I don't know why we're doing that. I guess that's the that's the code I finagled to figure out if our dx is going slow, our frame rate of our ostrich walk needs to be slow. But if our dx is big, it needs to be up to a certain speed but not past it. So this range here is the math I've figured out to kind of offset that into what felt like a good slow speed of animation and a good top speed animation. But yeah. So we're setting our viewport to the first frame if we're standing still and grounded. If we're moving and we're not grounded, let's increment the frames. Okay. Okay. So there's not too much vulture stuff going on. So it shouldn't be too hard to fix these problems, right? If I took out the jump counter, so they shouldn't be jumping anymore. And let's just see how their hitboxes kind of react. Okay. So it's like, there is facing right and facing left logic, which I don't know how that's actually a big mistake. So we need to just, upon our left collision, we are resetting our, here. So look, upon this left collision, we need to say if self dot facing right is false, then we need to become facing right, right? Self dot facing right gets true, but we have to do the not. If not facing right, then now we're facing right upon that left collision. And then same thing here, like we're saying, if we collide on the right side, if we're facing right, then we're actually self dot facing right gets false. Okay, let's see that. I just want to see him bounce. I want to see this guy bounce and walk the other way. Close. Walk the other way, you can make it. But look at this first guy. This first guy jumps down here, does a little bounce. God damn it. So yeah, he does a little bounce. He gets reset. Doesn't reset his frame instantly on that bottom collision. So what's going on? We're resetting our X. We're swapping our DX. So if we're left colliding, and remember our DX was a 1, a -1, I'm pretty sure. Then I'm saying, yeah, if you bump. Okay, so maybe we do need this. Sets DX to DX direction. Yeah, so maybe instead of doing any of this, well, no, I don't want to do this here. So here we were setting our, hold on one sec. Okay. Okay. See, look, I'm doing this same thing here, instantiating this null ground object upon not being grounded. Actually, that's an awful idea. Well, it's actually overriding. Fuck. Because this... Actually, no, hold on. This is in vulture. Okay, so if it's not grounded with its own... God, I don't know the reasoning behind this. I don't know the reasoning behind this. I think I'm trying to say we're setting our grounded to be false if we're not check grounded on whatever our ground platform is. But I don't get why we would be setting our ground platform to be an empty thing. Oh, it's because we're not check grounded. Okay, so that's the line I just added, right? Gosh. Okay. I think taking that out screws the... We need to check grounded for ground, because we need to set false if we're not grounded, meaning we need to fall off the platform, which is why that bottom vulture was just colliding here. So it should fall now, but look, notice how, sorry, watch how, see how we're falling now, and our vulture's wings are up because we're in a falling state. Yet, when we fall off here, see how wings not up, it just walks like an ostrich. So that tells me that our check grounded isn't being false. Yeah, our check grounded probably isn't getting set to false on this ostrich, which for now, I'm gonna only print out the second ostrich. Only gonna print out the second ostrich. So I can only, nope, first ostrich. I'm gonna only print out the first ostrich. So I can test this guy. Oh, see, that's working. See how he went to the fall animation. So something with more than one ostrich is kind of getting messed up there, because if all we do is add that other ostrich, that ostrich's fall doesn't become grounded. Yep. So that makes me curious if we turn off the first ostrich, yeah, turn off the first ostrich, and we'll watch this play out. I wonder if the collision is working on just one ostrich. No, it is not. So let's figure that out. Right now we're printing out the just collided on vulture 1, but we need to print out, what do we need to print out? Left collision on platform 3. Let's look at our platforms. If this is platform 1L, 2, 3. We want to see if there's a collision on platform 3 or not. So we want to say if vulture 1 colon run the function of left collides with the collidable being platform 3. Platform 3. Platform 3. Yes. 1L, 2, 3. So now we're printing if vulture 1. I'm just going to type in a platform 3 collision. Okay. And we'll see if we trigger the collision. That's step 1. Yes, it's triggering the true collision. Now let's take a look at what else is being printed there. Nothing. Okay. So we're gonna print out another value. I want to see our player's DX. Okay. See if that's changing. Vultures 1 dot DX. Okay, and we want to print it 10 pixels lower than our other one so we can read it. 32. Okay. Our DX is not swapping. So if you look at our DX, it stays a -1. We should be swapping our DX upon this true collision. And I'm curious if we print our X, if our X is changing and being updated constantly, or if something weird is happening. Okay. So it looks like it's still being affected by that dy. Or dx rather. So, okay, so I think that's the problem is I'm assigning a leftwards velocity every frame no matter what as part of the AI. But that can't roll like that. Because if the AI bumps into something on the left, it needs to be able to go right. Okay, that makes sense. So how do we say swap our dx, or like look at where our vulture's updated dx gets assigned? Right here. We're saying, hey, x gets our current x plus our dx, but look, every single frame we're saying dx is -1. So what we need to do is say, hey, dx is -1, but it's only -1 upon initialization. It can get swapped upon a collision, which is why we leave it out of the update loop. And now maybe we'll see it bounce. Okay. Yeah. dx is not getting set now. Here. I initialized dx to 0 actually when it should be -1. Oh yeah, moonwalking vulture. Nice. Okay. So this tells us we need we need to flip our vulture sprite depending on direction. So it's almost like it can be as simple as, because if you look, we have the facing right flipped on the x-axis here, depending if we're facing right or not. So all we have to do is flip this boolean appropriately, right? And since the vulture doesn't have any player input, it can't face a direction it's not moving. Actually, it's hard to say. Because our ostrich, if we bump the wall, will have a -dx, but I don't know if a AI ostrich bumps a wall, it has a -dx. So maybe we'll try to see that. Not what I wanted. Oh no. That was a big mistake. A big mistake. So yeah, what do I do here? Because I guess I'm curious if the enemy ostriches can hit a platform and face that same direction. No, they flip right away. They're opposite of us. See how they flip right away as soon as they collide on the side of a platform? But if we collide with a platform, we stay facing that direction. So they're a little bit different in that sense. Okay, that's a little nuance I didn't realize. But makes sense. So we're trying to... So this makes it a little bit easier on the vulture side, because we can just say, after we do our DT assignment, DT, DX, or whatever we do our leftward, rightward velocity assignment, that's when we say if our DX if our self.dx is smaller than 0, meaning it's negative, then our Boolean facing right gets false because we would need to be facing left. Then we can say otherwise. I like being verbose about this just because I feel like it saves us from something. So if our dx is greater than 0, meaning we're moving right, then we want to be facing right. And this Boolean here is what we use to trigger our render, whether we flip the sprite or not. So that should have the effect of making our vulture face the way it's moving upon collision. Nice. Okay. So that's the first time we've gotten an AI vulture to move the other direction. That's an oversight I had upon the initial making of it. But this is close because if ostrich collides with vulture, we need to reset our dx or flip our dx. So this is really close. I'm curious if our stuff gets all mangled if we turn on the other vulture. Yeah, it's okay. I see how it's messing up. And it is because it's sharing some data between the two. Because when one vulture falls, if one vulture's falling, no, it's hard to say. It's because vulture 1, they're overriding, they're sharing data when they shouldn't be. So we need to see what in our vulture table isn't a self that we're changing. Oh, well, I'll tell you right now, it's the vulture sprite. It's the only one that's not self, yet we're updating it for every vulture instantiation. So we need a self vulture sprite member so that it does get instantiated with each vulture, but they need to be different members because we're getting the render incorrect because they're sharing data with this vulture sprite variable when they need to each have their own. Come on. 98. Okay. I should have done the find and replace, but I'm learning. I still should just do it. Self.vulture sprite. I don't know if vultures can skid or not. I'm keeping that in for now. Okay. So save all that, and let's see if we boot with the correct animations for 2 different vultures now. That's looking better. Yes, they've each got their own fall animation. They trigger fine, they don't trigger each other. Sweet. So yeah, we need this left collision. We need this left collision with player to be different, right? Okay. But this is cool. They're working better now through those 2 fixes, which is really nice. I guess I'm curious where we're doing the collision with. We have a check grounded, we have a right collides. See, so I think our collides function is on our ostrich, not on our vulture. Yep, we have a collide with an enemy. And it's a true collision, a true AABB collision. Now, one thing I'm noticing is the left collide. When it's left collided, it wasn't resetting the enemy's X position. So let's see. Yeah, we don't set. And this is with the collision with the platform. We want the enemy collision. We want to see where we're using this collides enemy. So collides enemy, right? Okay, if we collide with enemy, if our vulture, if our Y's are the same. God damn, okay. Yeah, this is the only... Shoot, man. God dang. Shit. Okay. I want to say, if we collide, if our Y's are the same, if we collide with the vulture and our Y's are the same, we need to swap our DX, which we do. We put our, yeah, we negate, yeah. Well, no, if our vulture, wait, hold on. If our vulture is a positive, it'll become a negative. If our vulture is a negative, it'll become a positive. But we don't set our X position. See, look, we said this right here in our note. We said moves vulture to X not to be colliding, but we didn't do that. We need to do that. Well, look, we have a line right here saying our vulture X is getting assigned to be our ostrich's X. So yeah, we're keeping our ostrich the same. We're just moving our vulture upon that collision. So now the left, when an ostrich runs into me, when a vulture runs into me on the left, it should bounce right away. Well, that didn't look too great. Okay, let me see. Yeah, it should swap its DX. That's really weird. That's really weird. Yeah. That's really messed up. And that's not player DX, that's vulture DX, but that's really messed up, man. Those are working better though. It's just messed up. It's just real messed up. I want to see... I want to move the vulture's X to be the right side of us. We're going to flip our DX, flip vulture's DX. Like, let me just be cute and say, move us very far away. And swap vulture's DX, meaning we should swap its direction too, because our vulture's direction they're facing is based on the DX being positive or negative. So it should move it quite far. Why is that one so jank? Why is the left or the right collide is so jank? Oh, this is just self-collides. So we need to say it was assigning the X position to be the right collision. Okay, hold on. Okay. Yeah, we need a left collides enemy and a right collides enemy function. Okay. Um I guess we can kind of do a modification of this function. We know we're colliding, we just need to know which side we're colliding. So if the middle of, okay, so if this is our ostrich function, it relates to our ostrich position, we can say we're already colliding, which side is it colliding? We can say, hey, if the enemy's X is smaller than our X, it's a right collision. If the enemy's X is bigger than our X, it's a right collision, therefore do certain stuff. So I can write us a new function. Oopsies, I didn't know it did that. That's cool. God dang, function. God dang, okay. And our function is specific to our ostrich class, and it is called enemy left collide, or something like this. And enemy left collides will get true, you know, if our ostrich X, if our enemy's X, is smaller than our X, then we know that's a left collide. The enemy's X is smaller than, no, that's a, see, it's a little tricky because it's like, in terms of our ostrich, a right collision for the vulture on our ostrich would mean it's a left collide on the ostrich. So if our enemy's X is smaller than our ostrich's X, that means it's in enemy left collide collision. So I'm gonna do a equals there, and then I'm just gonna say return false, but I also wanna say, I only wanna populate, well, no, we'll only call this function if we are colliding with an enemy. So if we're colliding with an enemy, then we run this function on it and see if it's a left collide with the enemy, meaning we should reset the X position of our enemy to be the left side of our ostrich, versus if it's a right collision, we need to set our vulture to be, our vulture's X position to be the right side of our ostrich. So once we're colliding with an enemy, we say this function called enemy left collides, that takes in an enemy parameter, will be true if our enemy's X is smaller than or equal to our current X. Actually, I just want to say smaller than. So I actually want to do I want to do the more verbose way of, because I'm thinking if our enemies, or if we collide and our stuff is equal, if our, oh yeah, our x's want to be equal, so I think I just want to say if our enemy's x is greater than our self x. And I do this so that if it's 0, it doesn't accidentally populate true or false if it's a not side collision. Well, I guess it doesn't really. I don't know what I'm doing. Let's see. So now we need to say, hey, when we're checking a collision with an enemy, if that collision's true, check which side and then determine what to do based on which side. So we're saying right here, collides with enemy. Then we need to say, we can say, hey, we're instead of swapping, well, actually, see, this is the case where they're equal. So if they're equal, we're flipping our dx, but we also need to set our x position, but we need to set our x position based on okay. So I think this needs to be first, actually. I think we need to say if we're colliding with our enemy vulture, and this is self. If self enemy left collides with vulture, see, this is probably a bad name for this, because this will be true if the enemy collides with our left side. So we'll say if it's colliding with our left side, meaning that comes back as true, then we're going to set our vulture's x to be equal to, well, we assign into our vulture x variable a, let's see, if the enemy is colliding with our left, we need to set our vulture's x to be the left side of our ostrich. So our vulture's x should be our player's x, but shifted by the width of our player. Okay. And then we can be verbose about this too, saying else if. Else if not colliding and not left colliding, then we're going to set our vulture's x. This means we're right colliding. That means we need to set our vulture's x to be equal to the right side of our ostrich, which would be our self.x plus our self.width. Okay. And then, you know, if our y's are equal, none of this will get executed, because it won't be left collides and it won't be not left collides, because it's 0. At least that's the idea, because we're checking with our collides. If enemy's x is less than self.x, it'll be true. If it's greater than self.x, it'll be false. But if it's equal to self.x, it won't do anything. Is that right? So if they're equal, if they're the same y, it won't do anything. Then on vulture, 2 to 1. Okay. 2 221 vulture.x self me left collides vulture. Why you hate me? Then expected near vulture. 221. Gotcha. Oh, excuse me. Okay, let's see this. Okay. Collide with me and play nice. Reset your Y position. Or X position. Fuck. Shit. Oh, that's not it. That's not it. I'm gonna head to the bathroom real quick and I'll be right back. I'm gonna keep trying to figure this out though, so I'm not gonna stop. Be right back. So, what do we do, guys? What do we do differently to get us fixed here? We either make a left collision and a right collision and do things that way, or, see, I thought this would work. Enemy left collides if our enemy's x is smaller than our self.x. If our enemy's x is smaller than our... See, this isn't right. Yeah, if our enemy's x is on the left side of our ostrich... Fuck, hold on. Fuck, I need to come up with a better name than enemy left collides, I think. But an enemy left collides will be true if the enemy collides on the left side. How do we see if the enemy's on the left side? We're saying if our enemy's x is smaller than... Yeah. Okay, this might actually work. And then else, if this would be a enemy right collides, we're saying if our enemy's x is greater than our self.x and collision's true. Okay. So this width might actually be the ticket to save us here. Like, it might actually work. We're looking for this. Reset. Nope. Shit. Okay. Okay. I don't know what to do. I think instead of this enemy left collides, we just do two different functions. Well, see, and that's the hard thing. If we've got true AABB collision, we would, if we want to detect left or right collision, would we do an AABB collision on a left shaped rectangle? Like a half of a rectangle, right? But we already have collides enemy that does true AABB. So if we're already getting true AABB, why can't we figure out enemy left collides? Let's see the implementation of our enemy left collides and see if we're doing anything wonky. We're saying if we do left collide, we're setting our vulture's X to be equal to... Oh, this is wrong. Yeah, if we collide with if a vulture yeah, enemy left collides, that means we want to set our vulture's X plus... No. Vulture's X gets self.x minus a vulture's width. And if we're right collides, we set our vulture's X to be the right side of our character. Let's try that. So we're looking for, upon a vulture colliding with us, that we're resetting the vulture, making it go back this way. And it does not happen. It's hard to figure out where this is going wrong. We still want to be in this loop of vultures. Let's see if we only set our X position at the end here. Well, yeah. I'm glad we got that working. That's so... What's so weird too is that our player DX gets a weird truncated number. Well, no, that's not our... We're printing out that it's our player DX, but it's not our player DX. It's a Vulture 1 DX, I'm pretty sure. Which, gosh, where is it? Vulture 1 X. Okay. We fixed 2 bugs, but still got, you know, more. I really want to see if Vulture 1... No, I want to see if Player 1... I'm going to print out if Player 1 does a enemy left collides. Is that this? Let me do that. running the enemy left collides function on our player 1, passing in an enemy as our argument, which is going to be vulture 1 table. The index at our vulture's 1 table. Index 1 of our vulture's table. Let me see. Place state 132. I don't know if this vulture 1. Oh, shoot. Okay, well. Okay. This is totally fucked. I'm curious if our vulture 1, the first vulture we put in our index, is that top one? No, it's the bottom one. So the top one, vulture 1 is this bottom one. This vulture 1 is that left one. I want to print out vulture 2 then. I'm going to print out vultures 2, enemy left collides. Now, let me think. Enemy. What? 102? Enemy X. Gotcha. Okay. It failed because we don't have a vulture 2 because I had accidentally taken it off. It should work now. Okay, so now left colliding with this ostrich that's coming up. Yeah, that's already way wrong. Way wrong. Yeah, we're not flushing. Yeah, we're doing so many things wrong. We're gonna do. What do we do? I'm gonna look at our implementation of our collides with an enemy to see if anything can't be split out into 2 different functions, like we have right here. Nope. Where is our, damn it, ostrich collides enemy? Where do we use that? Right here. We use it for all of this through to here. So what we do for that true collision is saying, hey, if that true collision, if our y is equal and we're both facing right, I'm actually going to turn a vulture into an egg. If we're both facing left, I'm also... Actually, I don't know if that's right. If we've got equal y's and we're colliding, I don't think that should explode vulture into egg, actually. But the other two things, or the other couple things we're doing with this collides enemy true collision AABB function is we're swapping our DX. See, and we need fucking shit. I don't know the order of operations for this, man. So like while we're colliding with this, we're also saying, actually, no, yeah, we don't move our X just yet. I think I need to say something in our enemy left collides. I need to say something like, first of all, we're testing if our self is already colliding with our enemy. And if we are, then do all this stuff. If our enemy's X is smaller than the right side of us, that's not right. Hold on, I gotta draw this out. I just like can't figure out what to do here. Like, if a collision's detected, how do we know what side it's collided on? So, if there's two colliding, it's like, sorry, I'm just trying to draw this out. Okay. So if we reference it, shoot. Okay. Yeah, we need to say if our, God damn it. What's our enemy and what's us? Since the function is called, needs to be run on our ostrich should be the main square. And then our vultures are the ones we're comparing it to. So we're saying if we're already collided with an enemy vulture, then if our vulture's X plus its width is smaller than halfway, it would be our ostrich's X plus half of our width. Then that's a left collision. And a right collision would be if our vulture's X is greater than the vulture's X would be greater than our ostrich X plus half of that width. That would be a right collision. So we need to return true on left collision with an enemy if we're truly colliding, and then we check and say vulture's x plus vulture's width needs to be smaller than, oh, no, hold on. I have it here, vulture's x plus its width needs to be smaller than self.x, which is the ostrich, plus width divided by 2. So the divided by 2 is where we're checking the left quadrant collision. So if its x is smaller than if the right side of our enemy is smaller than the rightmost side of our left bounded colliding box, we're true. Else, if our enemy's x is greater than our ostrich's x plus our ostrich's width divided by 2. Then that would be a right collides enemy. And then otherwise, well, see, no, this isn't so great. Because this way, this isn't so great. Because right now this Boolean flip actually needs to be nil if it's not either one of these values. So maybe we can do that. And then we are so this now, these, we do need to set our x's still, but we can do this outside of our self collides enemy vulture function, because now we include in this function a check for the true axis collision, so we can kind of separate it out. And then if it's a left collision, we're setting our vulture's x to be the left side of our ostrich, Okay. And if it's a right collides, we're setting our vulture's x to be the right side of our ostrich. Okay. $5.93. That means we're missing hold on. Oh no. Where are we missing this if? One of the hardest things in coding is trying to see the indentation like this. Where are we messing up? We've got an end for here. We've got an end for here. Is this too much? No? Damn it. It's just a problem. We don't have a right end somewhere. It's always the worst shit to figure out. It doesn't even tell me. Okay. Yep. Ostrich. 59 end. Ostrich 593. Bro, what did I change? God damn it. I don't know. I don't know where it is. I don't see a single dangling if. I don't see a dangling if. Where did I mess it up? Where was I doing logic? Right here, no? God damn. Okay. Shit, man. Shit. Okay. Not exactly sure where we're going wrong. It just won't compile anymore. I'm gonna leave off the nil for now. I just want it to compile at this point. We're not having an end somewhere. You guys. This is driving me crazy. If we look at the traceback, it's in function require. Dependencies 8. Requiring ostrich. This sucks, guys, because it's like I'm right in the middle of having changed that code, but I'm not able to get it to compile at the moment. Syntax error. I mean, it's saying there's no end on function 101, which is our update function. No. At line 101. We need an end here. That's the problem. Okay. Bed argument 1 to string on 131. Where did it say nil expected? Value expected. So for debugging purposes, we can say if I don't know if I can do that. It feels like a super sin. That's not bad. See, it needs to detect the collision way sooner than it is. I don't see our left collision returning anything other than 0. Without returning 0 in that, we get a bad time. But that's only because we're trying to print out. You know, that's close. It's just I know we're not setting the X position right upon a left collision. So once left collides is true, our vulture's X needs to get set to our... Yeah, this is wrong. We're currently setting our vulture's X to be our ostrich's X. Oh no, left collides. If it right collides, we set our vulture X to our ostrich plus our ostrich width. That should be right. That should be right. But if we add 20 pixels of this and see if it gets set as soon as we detect that right collision, for now we'll turn off the fact that we're trying to do this. I'm so glad that bump's fixed, but... See, it detects the left collision, or the right collision rather, because it moves our X, but it detects it so late. Yeah, it shouldn't be able to move that far. should not be able to move that far. So that tells me something's wrong with our left collides code. This is not becoming false fast enough. So it's almost like our collides enemy isn't working just right, but we've got the true AABB collision. Let's just pick it up. 6. I just want to say it's not detecting the enemy collision. Like, I want to say we can take this out and we can do it right here. Would that help us? I didn't like that. Didn't like that. I did not like that. Enemy is a nil value. Okay. I think I know why. Yep. Okay, we need this in this block here. Because otherwise we're not cycling through. Actually, hold on. Collides with vulture. Yeah. We need it here in this vulture saying, hey, we're gonna set the vulture's X if colliding on a not equal. Oh, no. If we are colliding equal. Oh, fucking Christ. Oh, lordy. I need to do this. I do need to check if they're colliding. And if they're right here, if they're God dang. If their y's are equal, then we check to see what colliding side they are on and set the vulture's X appropriately. Come on, dude, bounce off me. It does it too late, man. And then it's DX, or it's... That's so weird. Why would Vulture 1 get a 0.33? Vulture 1's X gets a 0.33 for some reason. Upon a collision, which means our DX is being changed or something. I'm curious if that is the case. Okay. See, the collision the left collision is so busted. The right one's fine, which means the left enemy collision is fine, but the right enemy collision isn't triggering for some reason. So, well, actually, if I do want to say vultures 1, enemy left collides. This needs to be a player 1. This needs to be a colon. Enemy left collides with an enemy of our vulture 1 type. And then left collides with a vulture 1. Let's try that. There's no value by this function because we are not actually colliding. So we need to return a value when we're not colliding so that we can actually print it out. It's looking for here. No, vulture, no, fuck. God dang. I'm trying to print out the value of this function given the vulture 1 and our ostrich. So in our ostrich class, we go to that function. We need to return something if we're not colliding. And that thing, god damn. God dang. If we return a string called nil, not actually nil, but return a string called nil, are you allowed to do that? Okay. So I'm hoping this will collide as soon as we collide, but it actually takes a little time. I didn't even see it. Okay. Yeah, our left collide isn't even printing up. Well, it's hard to say because I could be wrong on the debugging. I want to see if... Confused? I'm confused. I want to print nothing. If it's nothing. Okay. Really, it's just nil all the way through? Big, alright, give it 1 and 132. I don't know, dude. Something's wrong in our left collide. It's not detecting it soon enough. You know, under our vulture collision, Yeah, we need to say if we collide with the vulture and our y's are equal, then if left collides, set it to the left side of our vulture. That one works fine. It's this one that we're setting our vulture to be the right side of our ostrich isn't working. Well, no, it's working. It's just not doing it fast enough. So it's almost like our left enemy collides function is just returning the wrong thing. So if the right side of our enemy is smaller than the midway point of our ostrich, and if the left side of our enemy is greater than the middle of our ostrich. This isn't quite working right, though. I don't think this is working right. You know. Let me just try something. We're going to take the true AABB collision and paste it. And then we're going to say only return true. We have to be fully colliding. Then we're going to say if we're colliding on the left side, then this function returns true. Else if we're colliding on the right side, return false. Okay. Let's see if that might help. Nope. 59 end. How did that mess up? Line 101. Okay. Probably the most annoying part of code is making sure those freaking code blocks get indented correctly. See, it's detecting a collision just way too late. Why does it do it so late? The right collision is fine, or the left enemy collision is fine. The right enemy collision just takes too long to flip our DX. So where are we flipping this DX? We're actually not flipping our DX. Okay. Okay, I think this is right. Because we need to put, you know, if we're colliding, our Y's are the same. If our left collide with the vulture, then our DX, if our ostrich left collides with a vulture, then our vultures, we're not fucking with our DX. No, yeah, we do need to fuck with our DX. Holy shit, man. Okay. So we're colliding. Our Y's are the same. What do we need to do to our vulture's DX if we enemy left collide. If our ostrich enemy left collides with a vulture, we need to take our vulture's dx, which would be a positive, and turn it into a negative. If we're right colliding with a vulture, then we need to take our vulture's dx, which is probably negative, and then we need to multiply it by a -1 to get a positive dx. And doing it then might make us turn around faster upon the collision here when it runs into me. Fuck, still goes in too far. It does look like it switches our dx appropriately. It just looks like this doesn't trigger the right collision. Doesn't trigger a right collision as soon as it should. So the right collision would be right here. If our enemy's x is greater than c, no, wait. That should be right. Let me just see what happens if I take that out. This left enemy collides is jacked. The problem here is I'm trying to use a Boolean for two relevant values that only get populated upon a certain condition. Because I only want this yeah, it's almost like I want, fuck. If I say else, return nil. Let me just see. See, we're not swapping his dx anymore because this is wrong. This is confusing. I'm not sure why it's been doing it. Great. Now we're not even getting that right. Okay, I messed up. We've got this. We're colliding. Then we need to check Okay. So yeah, we're saying if we're both facing right and we're colliding, explode a vulture into egg, but that's not necessarily the truth because of our X position. So we'll need to change that. I want to say that we need to use our beacon function right here, saying if our ostrich left collides enemy, right? Where is it? Enemy left collides. I think we need a better name for that. Bro. Left enemy collides. With every vulture. If left enemy collides with the vulture, then we need to set our vulture's DX to get negative DX because it would have been positive. So we will multiply by a -1. -1. Multiply that to our vulture's DX. Then we also need to set our vulture's X to be equal to, if the vulture collides on the left side of the enemy, we need to set our X to be our player's enemy. Our player's X shifted by the offset of our vulture width. Yeah. Then if it's a right collide, see, this is where the problem comes in. This is where the problem comes in, because we're trying to do logic based on a Boolean that doesn't get reset to anything non-useful. So this is why I'm thinking we just need this. Okay. I'm giving us another function called right collides. And even though, yeah, we just need this to be a separate function. Because we're getting some fucked up results. Okay, so this time we're going to return true if this happens. And if not, return false. Only return true if you're truly colliding and the enemy's X is bigger than the left side of our ostrich, meaning a right collision is true. This one is the same, but we need this to be else. Okay, so now we've got two functions, enemy left collides, enemy right collides. They both take in an enemy parameter argument. Then when we're cycling through our vultures, right here, we're cycling through our vultures for collision. We need to say, if we're collided, Then if we're left collided, we need to do this. Else if we're right collided, enemy right collides. Wait. Enemy left collides, enemy right collides. Enemy left collides, enemy right collides. Where are we? This is wrong. It's called enemy left collides. That's might be why we were getting wrong shit. For now, I'm gonna just see what this looks like in case it might have been the problem. Using the wrong freaking function that doesn't exist. Even worse. Even worse. Okay. Okay. If right collides with vulture, then we needed to, if our vulture collides on our right, it would mean, see, and this isn't quite right either. Fuck. Because it depends on which direction they're going. And how high. Fuck. Okay. Yeah, I need to like write out a flowchart of all this shit. But basically, we're truly colliding. Then we're checking if we're left colliding. If we are, we're setting this. Otherwise, if we're right colliding, then we need to set our vulture's negative dx to a positive dx. So we're going to set our vulture dot dx to be equal to math.abs of vulture's dx. We also need to set our vulture's x, and if we collide, ostrich, if enemy right collides, then we need to set our vulture's x to be the ostrich's x plus ostrich's width. Okay. Let's see. It's just really disheartening. You know, we're not even getting the, we're gonna scratch this. We're gonna scrap this, man. We're gonna scrap this. We're gonna redo it. We're gonna redo it. Yeah, I think tomorrow I'm just gonna rehaul that entirety because I don't know why it's messing up and we just need to get it fixed. I'm probably gonna do, I don't think I'm gonna do 3 different collision functions. It's almost like I need, I don't know what to do. There's a couple of weird problems. Yeah, I'm gonna have to just fix it later, man. I guess I'm a little toast. We will do a git commit with a message saying fixed aerial aerial vulture bug, and vulture collision bug. Still working on ostrich vulture collisions. Okay, we're gonna get pushed to our origin main. Yeah. So yeah, tomorrow I guess I'm gonna just rehaul all of our vulture collision detection, or even it's really our ostrich collision detection with vulture objects. Yeah, because we need to make like a flow chart, because the thing that gets tricky here is a side collision with a vulture could mean many things. If we're both grounded and our Y's are the same, and we have let's say, a right collision on our ostrich, we need to swap our DXs. But if we're in the air and we collide on the right, and the ostrich is on the left facing right, fucking Jesus Christ. Basically, I'm trying to say we can turn into an egg on a left collision. If our ostrich catches up to a vulture and it's facing the same way, then we have a left collides. That can turn it into an egg instead of just swapping our DX positions. Even if the Y's are the same height. So there's that. But then also, if our Y's are the same height and we're in the air, we get hit in the butt with a vulture. That can also happen. That would mean we deduct a life. So that's 3 scenarios right there where our Y's can be the same and we need to do different things based on the same detection. So that's where it starts to get freaky to try to think of how to scale it up like that. But first of all, we need to get ground collision working appropriately. Then we can worry about aerial collision appropriately. But yeah, I don't think the way to do it is to be continuing this 3 function array thing. I don't know. It's like I don't know. Yeah, it's tricky. But yeah, I think I'm gonna need to come up with something other than this. I think I need to do a true AABB collision and then determine in the logic, once there's a collision, determine those things like, hey, are we grounded? If we're grounded, do this. If we're in the air, do this. If we're in the air facing opposite directions, do this, or whatever. But we don't need 3 functions for this. We just need a true AABB collision. Then we can say, hey, if we are truly colliding, here's some code to see if we're right colliding, left colliding, whatever. You know, we can have it built out in branches instead of 3 functions like this. And we just need to get our vulture's X position to be appropriate on a left collision detection on our ostrich. So we're getting there slowly. You know, we fixed 2 bugs today, so we'll keep making progress. And I will see you guys tomorrow.